Hi students, welcome to SPSVERSITY. Today we are going to discuss about reabsorption in Henel's loop. In nephron, there is reabsorption in proximal connected tubule, Henel's loop, distal connected tubule as well as the collecting duct. So when I come to specifically Henel's loop, in Henel's loop the reabsorption is minimum. So why it is minimum, we look into this. So this region plays an important role in maintenance of high osmolarity and medullary interstitial fluid, that is the fluid present in the medulla. So the descending limb of Henel's loop, that is, when it comes to descending limb of Henel's loop, where it is permeable to water but almost impermeable to electrolytes, that is like sodium, potassium, like this. So here only water is reabsorbed. Whereas when you come to ascending limb, it is quite opposite. It is impermeable to water, but it allows transport of electrolytes actively or passively. So here, as it is impermeable to water, the filtrate becomes more concentrated. And it gets diluted due to passage of electrolytes to the medullary fluid. Okay. So here in Henel's loop only there is, in descending limb there is a reabsorption of water, and in ascending limb only allows transport of electrolytes. So here in this picture we can see each and every part, if you observe very carefully, that is proximal connected tubule, where there is reabsorption of bicarbonate ions, sodium chloride, water, nutrients like glucose, potassium. And there is secretion of substances like protons, ammonia. And it is clearly seen here in descending limb of Henle, there is reabsorption of water. Only there is reabsorption of water. Whereas when you come to ascending limb of loop of Henle, there is reabsorption of sodium chloride. So in this descending and ascending limb, if you observe carefully, there is a thick segment as well as thin segment. So in ascending limb, there is reabsorption of sodium chloride, that is electrolytes, but it is impermeable to water. So here, as it is impermeable to water, and here you can see that is the concentrated filter. And as the filtrate moves to distal connected tubule, DCT, where there is reabsorption of sodium chloride, water, bicarbonate. And there is secretion of K plus and H plus. So there is secretion of K plus and H plus. And when it comes to collecting duct, there is reabsorption of water. There is reabsorption of water. So like this, at each and every part of the tubular part of the nephron, there is reabsorption of water, nutrients, as well as there is secretion of harmful substances like ammonia, urea, such like of substances are secreted into filtrate. So here when you come to this, there is in distal connected tubule, there is reabsorption of sodium and reabsorption of water. So there is reabsorption of sodium and water, as well as that is bicarbonate HCO3 minus, and selective secretion of hydrogen and potassium ions. So the selective secretion of hydrogen and potassium ions. Ammonia, that is an ammonia to maintain pH of sodium potassium balance in the blood. So there is, you can see in DCT, that is distal connected tubule, there is reabsorption of sodium, bicarbonate, as well as water. At the same time, there is secretion of, that is H plus, potassium, ammonia to maintain pH and sodium potassium balance. Now we are going to discuss about counter current mechanism. So till now we discussed about the process which takes place in nephron. So this is a process which occurs in nephron, that is counter current mechanism. So when you come to counter current mechanism, the vasa recta and loop of Henle play an important role in this counter current mechanism. So vasa recta is the blood vessel which surrounds the loop of Henle. So vasa recta is the name of blood vessel which surrounds the blood vessel of loop of Henle. So here in loop of Henle there is descending limb and ascending limb. This descending limb and ascending limb. So here when there is this counter current help in maintaining an increase in osmolarity towards inner medullary interstitium. That is, in cortex it will be 300 osmoliters per liter in cortex and 1200 in medulla. Okay. So here if you see the picture very carefully, in vasa recta the flow of blood is in this direction. So it is a blood vessel where you can see the flow of blood. Whereas when you come to loop of Henle, the flow of filtrate in this direction, opposite. So there is a flow of filtrate in the opposite direction. And observe very carefully, in cortex the osmolarity value is 300 milliosmoliters per liter. And whereas when you come to outer medulla, in medulla there are again outer and inner medulla. In outer medulla it is 600, the value is 600 osmoliters per liter. Whereas in inner medulla it is 1200 osmolarity. That is, in medullary interstitium the value is 1200 osmoliters per liter. So here as you move from cortex to the medulla, the osmolarity is increasing. As you move from cortex to medulla, the osmolarity is increasing. So this mechanism where the osmolarity is maintained and the flow of filtrate in loop of Henle and the flow of blood in blood vessel vasa recta is in opposite direction. And this is mainly maintained by sodium chloride and urea. So NaCl is transported by ascending limb of Henle. So when you come to ascending limb of Henle, where there is only it is permeable to electrolytes. So it is permeable to electrolytes, that is sodium chloride, which is exchanged with vasa recta. Okay. Similarly, small amount of urea also enters into ascending limb of loop of Henle. So which is transported back into the tissue by collecting tubule. So that is, when you take ascending limb of the ascending limb of loop of Henle, there is reabsorption of that is NaCl, and there is secretion of urea. So due to this, there is a osmolarity is maintained. So this special arrangement made up of loop of Henle and vasa recta, it is called counter current mechanism. So where there is opposite flow of the filtrate and blood, as well as there is the osmolarity values. Okay. So this is about the counter current mechanism, where osmolarity and the concentration of sodium and potassium are maintained. Follow SPSVERSITY on social media. So till now we have discussed about the reabsorption, the secretion, the mechanism which happens in nephron. And we discussed about counter current mechanism which is specific to the vasa recta and loop of Henle. So now we are going to discuss about micturition. What is this micturition? So the process by which urine is discharged from the body, it is called micturition. So through urinary bladder, the urine is sent out through urethra. So whenever the urinary bladder filled with urine, so it gives a signal to central nervous system. So this central nervous system which gets a signal, that is when the urinary bladder is full of this urine. Again from central nervous system, this gives a signal to urinary bladder, that is stretching of urinary bladder. So when you take an adult person, so the urine is 1 to 1.5 liters per day, wherein this the urea is 25 to 30 grams, which is yellow in color, and the pH value will be 6.0. Okay. So micturition is the passing of urine from urethra when the urinary bladder is filled with the help of, that is, the signal received from the central nervous system. So now we are going to study about nephron osmoregulation. Okay. So how it is regulated, how osmoregulation is done in nephron. So the blood concentration is monitored by osmoreceptors in the hypothalamus. So hypothalamus which has sensors which will detect the changes in the osmolarity. Okay. So the amount of filtrate formed by the kidney per minute, that is glomerular filtration rate. So it is called glomerular filtration rate. Okay. So this glomerular filtration rate is one of the measurement for effective functioning of the kidney. That is amount of filtrate formed from the kidney per minute is going to be roughly about 125 ml per minute. That is, if you calculate per day, it is 180 liters per day. Okay. So roughly it is 125 ml per minute, or it will be 180 liters per day. If the concentration rises, what will happen? So the hypothalamus will release antidiuretic hormone, that is ADH. Okay. What is this ADH, antidiuretic hormone, which is released from, that is hypothalamus. So this hypothalamus makes the collecting ducts walls more permeable. The collecting ducts becomes more permeable. Okay. So more water is reabsorbed from the filtrate as the duct passes through salty tissues of medulla. Due to this, as permeability of collecting ducts has increased, what happens? It becomes more permeable, that is, more water is reabsorbed. You can see the kidney reabsorption. So when you take the filtrate, it has 0.03. So glucose, it will be 0.10. Amino acid 0.05, salts 0.72, proteins will be 0. Okay. And when you take the urine in mg per 100 centimeters cube, urea value will be 2, glucose 0, amino acids 0, salts 1.50, proteins 0. So ADH plays an important role in water reabsorption. So ADH is one of the important hormone which plays an important role in reabsorption of water, which is also called vasopressin. And this ADH, antidiuretic hormone, which is secreted in our body when our body is having deficit in water. So it acts on collecting ducts. So where the permeability of collecting duct will increase so that the reabsorption of water takes place. Okay. And there is another hormonal mechanism which plays an important role in excretion. That is called Renin-Angiotensin mechanism. What is this Renin-Angiotensin mechanism? So juxtaglomerular cells, okay, which secrete renin, they will secrete a hormone called renin. What this renin will do? This renin will convert angiotensinogen to angiotensin 1. And this is chain 1 where angiotensin 1 is again converted to angiotensin 2. What this angiotensin will do? So here what happens is this angiotensin acts like a vasoconstrictor which causes the constriction of blood vessels. So due to this, what happens is the blood pressure in glomerulus will rise. Finally, the increase in GFR. This, as and when there is a decrease in GFR, that is glomerular filtration rate, which is 125 ml per minute. The value of glomerular filtration rate is 125 ml per minute. This is normal value which indicates the effective functioning of kidneys. When there is less glomerular filtration, and to bring this value to normal, that is 125 ml per minute, so these glomerular cells will secrete renin, which will convert angiotensinogen to angiotensin 1. Again, angiotensin 1 is converted to angiotensin 2, which acts as a vasoconstrictor, which will increase blood pressure in glomerulus. Thus, finally, again the glomerular filtration rate is brought to normal, that is 125 ml per minute. So this angiotensin 2 along with this is not only the renin, along with it secretes aldosterone, which causes reabsorption of sodium and water in distal connected tubule. So this angiotensin 2 plays an important role in not only in increasing the GFR, at the same time it secretes aldosterone, which causes reabsorption of sodium and water, which acts on distal collecting tubule. So it acts on distal collecting tubule, which will increase the reabsorption of sodium and water. This is another hormone which plays an important role. Okay. And quite opposite to angiotensin 2, there is another factor, that is atrial natriuretic factor, which is called ANF, which has quite opposite action of the renin. That is, renin is a vasoconstrictor, it is a dilator, so which will decrease the blood pressure. That means when the GFR rate is high, to bring it to normal, to bring it down, so it will be secreted. So which will keep a check on angiotensin mechanism, Renin-Angiotensin mechanism. So here when you take the renin, the role of renin. So renin is an vasoconstrictor, so which will increase the blood pressure. As it increases the blood pressure, what happens is the GFR rate rises. That is, when it falls down, it will. Whereas when you come to aldosterone, that is atrial natriuretic factor, ANF, which is an vasodilator, so which will increase the lumen of blood vessels. So then what happens is the blood pressure decreases. So when the blood pressure decreases, again the GFR rate will come down to normal. So GFR comes to normal. So this is how the renin-angiotensin mechanism is there, which is opposite, that is atrial natriuretic factor. Okay. So here we have discussed about, that is basically hormones like ADH, which is also called vasopressin, which will increase the permeability of the collecting tubule so that the water absorption increases. Next, when you come to renin and angiotensin 2 mechanism, so when that is juxtamedullary cells will release renin, which will convert, that is the angiotensinogen into angiotensin 1 and to later angiotensin 2, which is a angiotensin 2 is an vasoconstrictor, so which will increase the blood pressure so that the GFR rate comes to normal, it is raised. The opposite is atrial natriuretic factor, which is a vasodilator, which will decrease the blood pressure, that is, it will be secreted during, that is, when there is a fall in, that is, when there is a rise in glomerular filtration. Again, it has to be brought quite opposite action, that is, angiotensin 2 and atrial natriuretic factor. These two are quite opposite in action. So thus how the hormones play an important role in excretion. Follow SPSVERSITY on social media. Okay. So till now what we discussed is nephron, kidneys, which play an important role in excretion. At the same time, there are many other organs which are involved in excretion, like lungs, which remove CO2, carbon dioxide, 18 liters per day, and water. Liver secretes bilirubin, the pigments bilirubin, biliverdin, cholesterol, hormones, drugs, vitamins, which pass out through digestive waste. That is, whatever the secretions done by liver, bilirubin, biliverdin, this whatever the drugs which we take after their usage, they are passed through, that is this. So it is one of the it removes this. Even sweat and sebaceous glands, which will eliminate sodium chloride, urea, lactic acid, etc. When you come to sweat glands, they will remove sodium chloride, urea, lactic acid. Sebaceous glands will remove sterols, hydrocarbons, waxes through sebum. So whatever sebum is secreted out, through this the sterol, hydrocarbons, waxes are sent out. That means not only kidneys, not only the what we call the nephrons play an important role in excretion, even lungs, liver, sweat and sebaceous glands, and sebaceous glands also play an important role in removal of the waste products from our body. Okay. So till now we have discussed about the role of kidneys, nephron and their hormones regulation, as well as we have discussed about the secretion of, that is, other organs which are involved. So now we are going to discuss about the disorders of excretory system. So one is uremia, where there is accumulation of urea in the blood due to malfunctioning of kidney. That means when there is no proper functioning of kidney. So where it cannot absorb urea, so that what happens is urea gets accumulated in the blood. Renal failure, when non-functioning of kidney stones, that is also called renal calculi, where there is accumulation of stones, that is crystallized salts, that is oxalates, that finally form kidney stone. Glomerulonephritis, that is inflammation of glomerulus of kidney. Okay. So these are different disorders which are seen, that is uremia, accumulation of urine in the blood, not functioning of kidneys, renal failure. Kidney stones, that is accumulation of crystallized salts, inflammation of glomerulus, that is glomerulonephritis. And nowadays it has become common, kidney stones, due to change in lifestyle. So here you can see. So it is a common kidney disorder. So they form chemicals. When chemicals in the area precipitate out and form crystals. They are generally calcium oxalate crystals, while others could be from uric acid and cysteine. So kidney stones are more common in men than women and can reoccur at any time. It doesn't mean that once kidney stones are formed, there is no chance of formation of again, there is chance of formation of kidney stones. Okay. What are the factors? Like nowadays we are seeing frequent infections like recurrent urinary bladder infections. So nowadays we are seeing many issues like urinary bladder infection. What is the reason for this? That is insufficient water intake and consumption of low levels. That is low levels of physical activity. Too much of vitamin C and D can lead to kidney stones. So one of the best ways to decrease the occurrence of stones is drink a lot of water and to change your dietary habits. So water consumption is very important to avoid the kidney issues. So nowadays the kidney stones has become one of the common problem. And next one, there is another one, that is urinary bladder infections due to lack of proper hygiene, less intake of water. These all are reasons for this, that is urinary bladder infections, kidney stones, these all are. So you can see kidney stones. What symptoms it will include? It will include severe back or abdomen pain, blood in urine, nausea. Nausea means vomiting sensation. Vomiting. How to diagnose this kidney stones? There are different medical diagnostic tests, including like X-rays, where the diagnosis of kidney stones can be done. So how to treat this? Okay, like there are many treatments has come to this, like passing, that is ultrasound sound, that is lithotripsy, to disintegrate the stones to small size. When the stones are made into small size, they can be easily passed through urinary tract. And if the size of stones, if it is more, it can be removed by surgery. It can be removed by surgery. So that's all for today's session. Let's meet in the next session. Thank you all. Follow us on social media on SPSVERSITY.